Hello, my name is Madison Ascione. I'm a junior undergrad at Georgetown University, and my research is on the use of multiple lines of sight to measure Faraday rotation through a coronal mass ejection. A coronal mass ejection, hereafter referred to as a CME, are large eruptions of magnetized plasma that get ejected off the sun. These CMEs produce energetic particles and enhance terrestrial current systems that can create geomagnetic storms on Earth. In order to understand the physics of CMEs, we use Faraday rotation to explore their magnetic structures. Previous observations of CMEs through the use of Faraday rotation have been limited to one single line of sight, but here I present to you the first successful use of multiple lines of sight to measure Faraday rotation through a coronal mass ejection. So Faraday rotation is the rotation of a linearly polarized signal after it propagates through a magnetized plasma. From Faraday rotation, we can get the rotation measure, which allows us to infer more information about the plasma density and the magnetic field of a CME. Faraday rotation gives a way to determine the orientation of the CME before it hits Earth. So we use data from the Carl G. Jansky Very Large Array in New Mexico. The VLA consists of 27 radio antennas, each 25 meters in diameter. We observed 10 linearly polarized cosmic radio sources occulted by the solar corona on the 31st of July 2015. I will be reporting on 2 of these 10 radio sources, source 0850 plus 1522, and source 0854 plus 1405. So these are radio maps of both the sources. On the left, we have source 0850, on the right, source 0854. Source 0850 has one line of sight, whereas source 0854 has 3 lines of sight, here, here, and here. These are clean maps of the total intensity and polarization structure of the radio sources on the reference day. And these images are both centering at a frequency of 1.424 gigahertz. The contours for source 0850 are 20%, 40%, 60%, and 80% of the total intensity I. And for source 0854, these contours are 5%, 10%, 20%, 40%, 60%, and 80% of the total intensity I. So on the day of occultation, there were 3 events that occurred. Our primary CME, which occulted all 10 of the sources, lasted from 1612 Universal Time to 2048 Universal Time. There were no notable flares that occurred on this day, but the wave mission on the WIND satellite did detect Type 2 radio burst. The fundamental Type 2 radio burst began at 1550 Universal Time and lasted until 2230 Universal Time. This was followed by a first harmonic Type 2 radio burst, which appeared from 1650 Universal Time to 1840 Universal Time, and a shortwave fade-out Type 2 radio burst beginning at 1930 Universal Time on the 31st of July 2015 and lasted until 0600 on the 1st of August 2015. Since fundamental Type 2 radio bursts are associated with a shock front, these bursts correlate with the footprints of the CME. So, our results. I have here for you 2 RM plots for the source 0850 and the source 0854. Source 0850 only has 1 line of sight, so we only have 1 set of data points. And source 0854, though it has 3 lines of sight, we only report 2 sets of data points, since these are the most sensitive RM results for this source. For source 0850, the RM values range from 0.68 to negative 0.95 radians per meter squared, and for 0854, the rotation measure values range from 1.37 to negative 3.53 radians per meter squared. Both sources are consistent with the coronal models, seeing as the calculated CME contribution for source 0850 is negative 1.67 plus or minus 0.006 and radians per meter squared, and the calculated CME contribution for 0854 is negative 1.74 plus or minus 0.05 radians per meter squared. So through this project, we demonstrated that by using multiple lines of sight, we were able to better understand and determine the strength of the magnetic field of the CME. In future research, we hope to continue using multiple lines of sight to evaluate the CME-induced Faraday rotation and compare the observational results to the model CME results, therefore allowing us to better forecast space weather so that we are prepared in the event that a CME is to hit Earth. Thank you.